Imagine for a second that you're in the kitchen cooking up a brand new dish. You check the recipe, open the pantry, and suddenly realize, oh no, you are completely out of salt. So what do? Well, you don't just freeze up, right? And you definitely don't start randomly throwing sugar into the pot. Instead, you think to yourself, okay, no salt. I need something salty. Let me go check the fridge for some soy sauce. You formulate a new plan, you act on it by actually opening the fridge, you observe the soy sauce, and boom, you adjust your cooking. This seamless, continuous loop of thinking, acting, and observing, that is the absolute hallmark of human intelligence. But for artificial intelligence, this has traditionally been a massive, massive hurdle. So what if an AI could actually think while it acts, just like we do? Welcome back to This Explainer. Today, we are unpacking a seriously fascinating research paper coming out of Princeton University and Google Brain. It's called ReAct, Synergizing Reasoning and Acting in Language Models. Basically, this paper introduces a groundbreaking method that combines an AI's internal reasoning with its external actions. It literally takes large language models from being just static text generators and turns them into dynamic problem-solving agents. It is super cool.
Here's our roadmap for today. We're going to quickly cover 1. The AI reasoning problem, 2. The ReAct solution, 3. Step-by-step methodology, 4. Real-world applications, 5. Results and limitations, and finally, 6. The impact and key takeaways. Let's get right into it.
Starting off with Section 1, the AI reasoning problem. Why exactly is it so incredibly hard for AI to complete complex, multi-step tasks in the real world? To really understand the problem, we have to look at how AI currently operates in two completely isolated silos. On one side, we have chain of thought prompting. This is reasoning only. The AI thinks step by step using its internal knowledge base, which, is great for math or pure logic, but it's a static black box. Because it can't check the external world, if it doesn't actually know a fact, it just makes it up. It hallucinates. Then, on the totally opposite side, we have act-only models. These are designed to interact with environments, like clicking web links or playing games, but they act completely blindly based on immediate observations. They can't reason abstractly about high-level goals, so if a task requires any sort of long-term planning, they just fail. Basically, one is all brain and no hands, and the other is all hands and no brain. Moving to Section 2, the ReAct solution. So how do we actually give the brain hands and the hands a brain? The answer they came up with is ReAct. We can define this as a prompt-based paradigm that perfectly synergizes reasoning and acting in large language models. It does this by generating verbal reasoning traces, which are basically the AI's inner thoughts, and task-specific actions. And it does this in an interleaved, alternating manner. The reasoning helps the model track its goals, update its plans, and handle any weird exceptions. Meanwhile, the actions allow it to actually interface with the outside world, like, say, searching Wikipedia, to gather the exact information it needs to continue its reasoning. The authors highlight this beautifully. They state, a unique feature of human intelligence is the ability to seamlessly combine task-oriented actions with verbal reasoning. To put that into everyday terms, think about troubleshooting a broken TV remote. You use your inner speech to realize, hey, the remote isn't working. Then you actively search for a solution. Maybe you pull up Google, type in a query, read the result, and say to yourself, okay, I need to use the app on my phone. ReAct essentially forces the AI to mimic this exact, incredibly human cognitive loop. All right, Section 3, step-by-step methodology. Let's see how this all builds into a continuous feedback loop. The methodology breaks down into a continuous 3-step cycle of input, process, and output. First up is the input, or the observation. The AI takes a look at the current state of its environment. Maybe that's a search result page, or maybe it's a room in a text-based game. Next is the process, or the thought. The AI literally writes out a verbal reasoning trace. It might say something like, okay, I see this remote was made in 2005, but I need to know what devices control it today. I should search for compatible devices. And finally, the output, the action. The AI executes a command in the environment, like typing out that new search query. That action then generates a brand new observation, and the loop just keeps repeating until the task is completely solved. Section 4, real-world applications. Now let's take this abstract loop we just talked about and apply it to some concrete, real-world tasks. The researchers tested this across 3 massive, very distinct domains. First, hot pot QA. This involves multi-hop reasoning. Think of a complex trivia question where you have to look up one fact just to figure out what the next fact is you need to search for.
Traditional models just guess blindly and hallucinate. But ReAct, it actually uses a Wikipedia API to search for facts step by step. Second is AlfWorld. This is a text-based simulated household where the AI has to find and interact with objects. Traditional models totally get lost and fail to track their sub-goals. ReAct, on the other hand, uses its inner thoughts to track its state and apply actual common sense, like figuring out that a desk lamp is probably sitting on a desk. And third, Webshop. This is a simulated online shopping site with over 1 million real products. Traditional models crash and burn trying to navigate noisy text and menus. But ReAct actually reasons about product attributes, actively deciding which color or size to pick before it ever clicks the buy button.
This brings us to Section 5, Results and Limitations. The big question, did this methodology actually work? Well, the results are honestly staggering. Take the ALF World Benchmark, for example. The Butler model, which is this imitation learning agent trained on tens of thousands of expert human trajectories, only managed a 37% success rate. A purely ACT-only prompted model bumped that up to 45%, but look at the leap with ReAct. It achieved a massive 71% absolute success rate. And the craziest part, it did this while only being given a couple of examples in its prompt. Just by allowing the AI to pause and think about its sub-goals before it acts, its performance literally skyrocketed. And this brilliantly illustrates what happens on knowledge retrieval tasks. The researchers found that while ReAct is amazing at pulling factual data and avoiding those pesky hallucinations, traditional chain of thought is sometimes still better at complex logical structuring. So they just combined them. If ReAct gets stuck, it switches over to internal logic. If the internal logic gets unsure, it switches back to ReAct to search the web. This hybrid model easily scales to beat either method used entirely on its own, achieving state-of-the-art prompting performance. It's truly the best of both worlds. However, to be totally fair and scientific here, we definitely need to talk about the limitations. Because ReAct relies so heavily on a strict structure of observing, thinking, and acting, it can sometimes reduce the model's flexibility to just free-form reason. Plus, since it relies on external feedback, if it does a Wikipedia search and gets a totally empty result, well, that non-informative observation can severely derail its entire thought process. When it gets confused like this, it is highly prone to getting trapped in repetitive action loops, basically searching for the exact same wrong thing over and over and over again. Finally, Section 6, Impact and Key Takeaways. Let's wrap this up. Why does all of this actually matter? Here is your summary checklist to take away from all this. The problem: large language models have traditionally separated reasoning from action, leading to static knowledge and a lot of hallucinations. The solution: ReAct interleaves internal thoughts and external actions to create a dynamic human-like feedback loop. The results? We saw a massive 34% increase in success rates in text-based environments and a 10% jump in complex web navigation. And the impact: by transforming a static AI into an interactive reasoning agent, ReAct doesn't just improve accuracy. Because we can literally read the AI's thoughts at every single step, it gives us highly transparent, interpretable AI. If it makes a mistake, we don't have to guess. We can see exactly why it made that mistake. I'm going to leave you with this somewhat provocative thought about the future. By giving an AI an inner monologue that is tied directly to external actions, we have fundamentally bridged a major gap in artificial cognition. If AI can now reason, act, and observe seamlessly in digital environments and text games, well, how long until it's embedded in robotics, navigating the physical world, and cooking in your kitchen right alongside you? It's a fascinating question and one that definitely makes you want to keep a very close eye on this field. Thanks so much for joining me on this explainer, and keep learning.